Yeah, it was a good day. Good day, Sean. What time to be alive?
Can you see my slide?
Yep.
Yep.
Okay. Then, and today talk about overview of device and circuit design. And this is one of my background. Okay. Then outline is like this, and the procedure of and the device design, and device and the circuit design. Sorry. Then first point is and the device design, and for silicon-based device, OLED and Josephson device. And the second point is circuit design, and for OLED display and quantum devices. Then this one and outline of and the procedure of device design. As a first step, and we and have to design a three-dimensional device and structure, and selection of material combination, and fitting and and extraction and fabrication parameter to optimize and the device three-dimensional device structure, and uh, extraction of device parameter for circuit design. As second step, and we use SPICE circuit simulator. Then to optimize of system performance and determine of operation condition, and like this. Then here and circuit map, okay, and with netlist. Then as a third step, and we focus on fitting to fabrication, and including and film deposition and photolithography and etching, and additionally, and we feedback to device circuit design again. And the first point is and device design and for silicon-based transistor. Then TCAD means technology computer aided design. And first as this, and this picture and indicated and process simulation, and example for ion implantation, and for silicon-based transistor. And here, gate electrode and source and drain here, and P-type and N-type. Then second step, and the device simulation, and the parameter setting of MOS-FET, and for example. Then, and from this TCAD and result, and we create and electrical characterization and of MOS-FET, and for example. Then this one and the device design for OLED. Then here, okay, and same of silicon, and we can, okay, and make device simulation, and depending on and device structure parameter. Then and we obtained and optimized parameter and for OLED. Then from this and device simulation, and we and can create it and voltage and anode current and luminescence power. And here, okay, supported can support and electrical characterization of OLED. Then and the second, and here and additional and simulation and different from silicon device, and because and OLED device and have and optical performance like this, and here ITO thickness and ITO thickness TAPC here, and whole transport layer thickness. Then this case and very useful for optimization like this, and thickness combination, okay, and and very, and depending on, you know, and EQE and peak of spectrums. Then third one, okay, and device design for Josephson device. Then honestly, okay, and commercial simulation tool and for Josephson device, and then not released yet. Then this one, okay, and recent, but and 3 or 4 years ago, and released and for research scientist and a physics-based TCAD simulator and for Josephson junctions. Then synopsis means, you know, and the TCAD and the distributor, and they limited and limited, you know, and released, and this TCAD simulator. Then I and have and contacted them, but very limited and user and using this one. Then you can see and current voltage and performance of Josephson junction depending on temperature like this. Okay. Then second section and indicates circuit design and using SPICE and mixed signal simulation. And mixed signal means and digital and analog and signal. Then SPICE and simulator and simulation program with integrated circuit emphasis and have been developed UC Berkeley around 50 years ago. Then, and we can use a very low cost like this. And here shows and LT SPICE and control panel and ring oscillator, for example. And this one include P channel and N channel FET numerical model and using parameters extracted from device characterization. Then, and you can see here N-type, P-type and N-type and combination of inverter. Then 11 stage and a ring oscillator and created and this and periodic pulse. Then here, okay, an example of and OLED display design. Then and here and pixel circuit, okay, and with 24 micron and 48 micron and for OLED display. Then and the single pixel include, you know, and the 7 transistor probably, 6 transistor, sorry, 6 transistor and a control capacitor and OLED like this. Then and this structure, okay, and operated by and combination of pulse like this. Then and programming, you know, and operation voltage here and between 2.6 and 3.3 volt to control and the luminescence of OLED and for each pixel. Okay. And here, okay, example of and design for OLED display. Then this one, okay, circuit design and for quantum devices. Then and roughly and quantum devices and is categorized and for cryogenic quantum devices and like a Josephson junction and room temperature optical wave guides. Okay, and this one and have different, you know, and design methodology depending on and different materials. Then cryogenic quantum devices and usually and operated in very low temperature and less than millikelvin. Then entangled element and photon. Then and the frequency or wavelength is and usually mega or gigahertz. Then and here and the process rule is big difference each other. Then Josephson junction, okay, submicron designed, okay. Then and in case of and room temperature optical waveguides and operated in room temperature and entangled photon and have several hundred nanometer wavelengths. Then and process rule is and so big, several micron. Okay. Then here, okay, and a difference of and cryogenic between cryogenic quantum device and room temperature optical waveguides. Then and Josephson, Josephson junction is very small here, very small here. Then and other coupling device is so big like this. Then on the other hand, and optical waveguide and have several micron size like this. And here and designed, and optical photon, okay, and have relationship in here. And this one and the phase shifter. Then this design, okay, and can be obtained and by commercial simulator. But and cryogenic quantum devices and we don't have and the commercial level and the design simulator. Then here, okay, and in case of cryogenic and quantum device, okay, and TCAD SPICE layout tool and we need, but and not support cryogenic devices. This is big problem. Then in case of, and optical and waveguides, mode or interconnected here is name of simulator. Okay? Then and the mode, okay, can support waveguide structure design. The interconnect, okay, and can support circuit design. Okay. Then but and here, okay, very useful for and small integrated and circuit, but and not suitable for and higher integrated circuit and with and quantum entanglement. And here and then still not easy and to and improve. Here and just reference and join us. Okay? And here, okay, and SPICE-based simulator, okay, and for cryogenic device, okay, and still under research. Then and here other type, TCAD already, Then and 3 years ago, I have tried and numerical and simulation tool and for optical waveguide design. Then and mode simulation tool and can calculate, and the relationship and this at quantum and and wave function like this and a relationship here. Then interconnect and can support and optical circuit like this. Then and modulated and pulse, okay, and have been created like this. Here, okay, and very low level integrated circuit and have been supported and numerical mode and interconnect and simulation tool. But and these and the simulation tool, okay, and very expensive like this. All right, that's all. Here is and overview of and design methodology.
Thank you. Any questions, comments? It sounds like this software gap could be a good candidate for a quantum startup. Quantum startup with lots of money.
Yeah. Then,
yeah.
yeah, if we want to design, okay, optical waveguide, okay, and we can select and this simulation tool. Then in case of and OLED and silicon-based and the integrated circuit, and we can and select several types of and the simulation tool and commercialize the simulation tool.
Okay. Well, let's give Hirai that one.
Okay.
So next week it's Kareem. You're up.